To understand EV charging infrastructure, first we have to know what EV charging infrastructure is.
The government is promoting two important measures to manage the EV charging load. The first measure promotes to use of renewable energy to charge electric. We are using solar power. Our solar power generation is very huge. Lot of thousands of projects are now. We are encouraging people for making solar energy.
So many countries have done significant progress in EV charging infrastructure technology. India has also made a lot of progress in this particular field.
How power electronics principles are applied there?
It will primarily consist of two important parts. One is power electronics, another is VLSI, which also includes communication. Right? Reliable chargers, which are small. So there is a requirement of various technologies that are required to make the charger both small as well as reliable. So mostly these chargers run on digital control, whether we can do fast charging or not. Yes, of course you can charge it fast, but that comes at a certain price.
So welcome to this special podcast on advanced EV charging infrastructure. We are going to discuss about this technology and the prospective future in this particular ever-evolving field with Dr. Shantanu Mishra. He's a senior faculty at the Center for Automotive Research and Tribology at IIT Delhi. We are going to launch a program on advanced certification program in this EV charging infrastructure, which will be spearheaded by Delhi Science and Technology Cluster, which is a flagship program of the Principal Scientific Advisor to the Government of India, in collaboration with the CART of IIT Delhi. So in this particular podcast, we will be asking a few questions from Professor Mishra, and we'll try to learn more about this upcoming field and how this will be going to help the student community and the working professionals. So good morning, sir. So I'm representing DRIVE, the PSA's office flagship initiative, which has got a mandate of inventing new technologies, facilitating and piloting new technologies, and also one important initiative of imparting skill development and high-end skill development among our youths, whether they are the fresh graduates or working professionals in the industry, with the target of creating skilled manpower, a large pool of skilled manpower in India, so that they can become the backbone of India's growing economy and our technology and our journey towards the modern technology regime. So that's why we have partnered with you, the CART, and under your guidance, we'll be launching several courses. To start with, the first courses will be on the design of the advanced EV chargers. Okay. So this is our whole initiative, and we wish that this whole journey will be very beneficial to our country and especially among the youths of India.
Okay, I'm glad that you reached out to me and to others inside IIT Delhi.
Great.
We will be honored to help you in any way we can to improve our skilling.
Thank you, sir. So, sir, welcome to this podcast on the EV charging and infrastructure development. So, to start with, please let us know a little more about how this EV infrastructure is being created in India and what is the stage of development on a global perspective.
Okay. See, to understand EV charging infrastructure, first we have to know what EV charging infrastructure is. Right. So we have grid and we have to charge our car. Car is battery, DC. Right. So there is a conversion from this grid power to car battery power, which is at DC. So this is done by a thing called a charger, EV charger. So this EV charger is like, it looks like it is a simple thing, that it is a converting AC into DC. But actually it is not that. It has to be in a system. This EV charger has to be in a system. That is what is called a EV charging infrastructure. What that means is that when an EV charger is there, so apart from the EV charger, there are many other things that work in tandem with that EV charger. Communication with the EV as well as communication with the grid. Okay. Then battery storage. Battery storage means when we demand a lot of power from the grid will have problems. So therefore we have to have storage, which will act like a buffer. Right. So this is what EV charging infrastructure is all about. So now coming to your question, what is the status of it? So the status of it is obviously dependent on the country, right? So many countries have done significant progress in EV charging infrastructure technology because it is many technologies coming together, right? So especially if I want to name some, North America, Europe, Korea, China, Japan. So they all have made significant progress because they have made significant progress in communication technology, battery technology, as well as charger technology. So combining them is of course there. And if we think about India has also made a lot of progress in this particular field. So that will be your answer.
Okay, nice. If we are to give a kind of a ranking on a global scale, where do you put India vis-a-vis these countries which you have named, sir? Starting from the top, because we have seen that America had quite an edge in the initial stages, but right now we are seeing that many companies coming out of China, mainland China, they have also done rapid progress. But there are still the legacy companies like Infineon and others who are doing cutting edge research. So how do you see these kind of competition, the healthy competition, and how we can compete with them?
Okay, so we are actually not far behind if you think about it. The only thing that probably as a country we are trying to do is evolve in this field and be self-reliant. Okay, because as you can imagine that many of these technologies are still imported from the from the foreign countries, right? And anytime you are having dependence on other countries for your own livelihood, that is actually a problem, because there we have to develop ourselves. So we are on the right track, we are developing, and that is where government is putting a lot of effort, and we have been given a mandate that we have to train our manpower, we have to be better in our research, and a lot of startups are being promoted. So we are actually on the right track in this particular
nice, great. Sir, you are essentially an IC designer who has been trained in the US, and you have spent your initial years in industry in a very reputed company. Now tell us a little about your journey from industry and then coming to academia, and especially right now you are working as a senior professor in the CART in IIT Delhi. So just tell us a little about the whole of your journey and your present assignment.
Okay, yes, long back I was a graduate student at Florida. I worked in a company called Infineon. It used to be called International Rectifier. So there my job was to design ICs and apply those ICs to server power supply. So many of my designs are used in IBM Jet series server. So, but that was what I used to do after I completed my doctorate. So then I came back to India to join IIT Kanpur, where I was there for 15 years. And I have been working on power supply design since then. So mostly in the initial years and for at least 10 years after that, I worked on renewable energy systems, where microgrid implementation was my core interest. But then I moved to CART, where now EV is my core interest. But said that, I will also from a lighter note say that I am the same person who has the same skill set. It is just that the same skill sets are applied to different fields.
Right. Sir, tell us a little more about CART's mandate and how it is delivering on those mandates.
CART was actually, it is a relatively newer center inside IIT Delhi. Professor B.K. Panigrahi, who was the founding head of that, and being a good friend of mine, he invited me to join CART, and I am here. So now in that respect, what we generally do is that we conduct courses, we do a lot of industrial research. So that is our mandate. That is what actually we do. And currently what we are focusing on is not only charging infrastructure design, battery technology design, and health automation, health monitoring and automation. All these fields we are trying to kind of do research on these fields. And apart from research, we are taking a lot of effort in floating a lot of courses for our
skill developments and manpower. Right. So if you can just tell us a little more about how EV charger design, both from the theoretical part as well as when you implement in a lab and at an industrial scale, how the whole experiences are different or is unique, since this is a new evolving field and multiple new technologies are coming every day. So how this whole experience becomes very unique, so to say.
Okay, I'm glad that you asked this question. See, when we hear electric vehicle, it somehow gives an impression that it is electrical.
True.
Okay, it is of course not true, right? Why? The reason is that electric vehicle consists of many technologies, chemical engineering, battery, which also consists of material science, right? Then mechanical engineering, how to enclose the EV charger so that weather doesn't affect it. Okay. Then thermal design, mechanical engineering again, right? So where we take care that like the heat that is generated by the charger, how is that easily dissipated without creating fire? All right. So these are all subsidiary technologies. I'm only naming a few of them. Subsidiary technologies which are actually extremely important for EV charger design. Said that EV charger, you cannot float it in the air. It has to be there has to be a proper place that has to be made. So civil engineering is involved there. But see, what that means is that there are many technologies that are actually coming together to make this EV charger charging infrastructure work.
Okay.
All right. So hopefully I gave you an overview of what are the type of engineering that are required.
Right. So when we come and focus only on the charger principles, sir, and I'm asking from the viewpoint of power electronics and embedded systems, systems, in which you are the expert. Just give us some idea of how power electronics principles are applied there, and how that field is ever evolving. Because what general principle says, or what general masses understand, is power electronics is all about the thyristors and various kind of diodes. But now with the advent of this modern communication technologies also, and the various charging principles, just give us some idea of how this field has evolved in this coming future.
Okay. So, see, as far as electrical aspect of EV charger is concerned, it will primarily consist of two important parts. One is power electronics, another is VLSI, which also includes communication. Right. So let me break down a little bit. So if you look at power electronics, when we think of a power electronics in a charger, it consists of various components, which will consist of semiconductor switches, magnetic design, capacitor design, and heat sink, PCB design, and things, subsidiary things like that. Right. So they all actually come together to improve the technology. Right. So one of the major challenges there is that how do you make things more efficient, and how do you make things more reliable? Because in a country like India, where a charger can be installed up there in the Himalayas, no one has, it's very hard to go there and fix the charger. So we have to make technology which are very, very reliable in one aspect. In other aspect, we are also having cities which have space problems. So we have to have reliable chargers which are small. So there is a requirement of various technologies that are required to make the charger both small as well as reliable. Right. So in that respect, there are many technologies that are used. So let's say we want to make the charger reliable, but not that efficient. There is one type of technology that is used. But if you want to make the charger extremely compact, but reliability is, 3-4 years reliability you want, then there is another type of technology that is used. So these are all the technologies that actually come together to make the charger. Similarly, when we think about power electronics, we think that only electronics is used. Okay, no, we do use a lot of thermal design, so where mechanical engineering is used. So we do use a lot of like heat flow aspects. So those things are also there. So to coming to the second part, that is the communication and VLSI. So communication and VLSI also plays an important role. So mostly these chargers run on digital control. The reason is that whenever we want a control on the charger from outside, then we actually need something called a digital control. Okay, so where microprocessors or microcontrollers are used, because they are more easy to program. Okay, and they also are very useful in integrating with the communication protocol, because when there is a charger, it has to communicate with the electric vehicle. Otherwise, how will the charger know how much the battery has charged, etc.? So this communication between the electric vehicle and the charger becomes easier when we use digital controller. So that aspect is also very, very important in this kind of charger design.
Great. So, and sir, you are working very closely with multiple Indian companies who are into the EV sector, especially the charger designs. What are your experience when you interact with the technocrats working in this company? How adaptive they are with the newer technologies, and what is the status of charger design in India, especially?
Okay. So the status of charger design is very good. Actually, there is I will say, a hunger to make things in India.
Okay.
So there are three aspects to it. Like in the olden days, we used to import things to India, right?
True.
So slowly, in the last 10-15 years, we are making in India. Making in India means you get the components, put them together and make in India. Now we are slowly going towards made in India. Made in India means the components we are innovating ourselves. So this is actually a very important aspect of any society. So when you make what goes into your system, right? So that there we are actually slowly going towards. So coming to your question, when we interact with these companies, see, at the end of the day, the companies have to make money. They are answerable to.
Yes, they're stakeholders.
So they are very adaptive. They have to be very adaptive to make things that are cheaper, and they will be at the cutting edge. So that I have clearly seen from our Indian companies, and I have seen a hunger from our startup to make things in India and build things and generate employment for us. Right.
So, sir, one very important aspect of EV is that when we compare EV with our traditional IC engine vehicles, so one critical parameter is that the charging time of our EV vehicles is quite lengthy as compared to getting refueled at a particular station. So how you see this particular problem getting addressed in the near future, especially coming to India? Because we have seen some reports from China and Western countries that they have come very near to having the fast charging devices which can charge a particular kind of a vehicle which can run up to 100 or 120 miles in around 15 to 20 minutes. So is it a near possibility in India, and are we able to will we be able to achieve that in the near future?
Okay, there are two aspects to your question. The first aspect is whether we can do fast charging or not. Of course you can do fast charging. In fact, UPS is nothing different than a charger. We have hundreds of kilowatt of UPS still running. All our data centers run on it, right? So making that is not difficult. Okay, but now the question is that what is the repercussion of that, right? So the repercussion is that we have to understand the battery is like a human being. Like we eat, in 15-20 years my daughter will grow from this height to this height, right? So what that means is that it's a chemical process. So chemical process, when things happen in a chemical process, it takes time. So battery charging is like a chemical process. So yes, of course you can charge it fast, but that comes at a certain price. Things like the aging of the battery will be faster. So if you every day you charge it with a fast charger, then aging will be faster. But this is where the major research is going on now. So major research is going on to make the charging of the vehicle faster without affecting or degrading the aging. Okay, that is one thing. Second aspect, which probably I should point out because we are at the right point. So we actually have a requirement to use batteries which are sourced from India. Okay, because at the end of the day we have to be dependent on ourselves. So there are two aspects to battery research. One is making battery that are sourced from India. So many companies, many research labs are working on it. And the second part is that can this material that we are using for battery are good enough, as good as the present day technology, and will it be such that it will not degrade the aging of the battery? Like without affecting the aging of the battery, can we do fast charging? So these are the two aspects we have to basically people are looking at, so that it can be made better. This EV charging can be made better.
Okay, nice. Sir, we are planning to launch this certificate program in advanced EV charger design. So tell us a little about this whole program and this curriculum, because this has been under your guidance that we have designed this whole program. So please let us know a little more.
Okay. To start with, like it may seem that I am the one who is driving the program and things like that. That is actually not true. The mandate actually comes from our government. So when DRIV came to us, DRIV is actually a
PSA initiative. Yes.
So when they come to us, it is actually an honor to be a part of this kind of stuff where we train our manpower. Okay. So now coming to the 4-day program. So the program is made in such a way that we will both have theory as well as practical. So the program has been divided into 4 days. So in the first day, we will be working on converter design, and in the afternoon we will be doing the lab on converter design. Then on the second day we will be doing the theory on charger implementation, and then we will be doing the lab on charger implementation. On the third and fourth day, we will be exclusively focusing on embedded system design. That means this charger control, how do you do it in a digital controller like a microcontroller or DSP. So to give you a perspective, the program is designed such that once these 4 days are over, it will be an intensive course to let you know what are the technologies that are important to make a contribution to EV charging field.
Nice. So since this kind of program is very, very new in India, sir, but we have seen that some generic kind of charger design courses, either in a traditional engineering college course curriculum or as a short-term certificate programs, we have seen being launched at some of the institutions. How you feel that this particular program will be different, markedly different, and what are your expectations from the students once they complete this course?
Okay. See, I will not go so far to say that this course will be very great or something like that. See, we all as academicians, let it be in any college or any institute or any IIT or as such higher educational institute, we are actually trying to promote and train our manpower. And of course it cannot be done by one guy. It is done by many people. Okay, so that is the first part of the answer. The second part of the answer is that it is not like this program is unique or something like that. There are many programs going on in other IITs as well as other partnering institutes which are actually as good as this. Okay, so now let's come back to our program. So one of the things that I feel is will happen in this particular program is, in this particular program, we will not only go through the theory, but also we'll have hands-on experience. Okay, so that will be a very good addition you need to, for students, because now when you do a theory and in the afternoon you see that theory working in practice, that probably gives a lot of
exactly, very true, sir. Actually, this particular part is the unique portion of this whole initiative, that the students who are going through the theory classes in the first half, immediately in the second half they will be having the hands-on experience on the real-time hardwares, and they can have the first-hand feel of how the final product looks like. And when they will be going to the industry, they also will be not be looking at anything very new. They will be having some kind of idea after going through this program at how the chargers function and how their outputs actually look like that. So I think this is the whole uniqueness of this program. So
I wanted to add one more thing to what you pointed out. See, one of our government mandate is skill development.
Yes,
right?
very true, sir.
So what we feel in this particular course is that by having this practical implementation and theory hand in hand, right? So that will spark people not only to take job but also to become entrepreneurs who can, because like once they understand that they can only make even one small thing and still be best at it, and that can be used in chargers or things like that. So that actually gives a lot of excitement to our students are very hungry for knowledge, right? So this particular course will try to
impart that skill and yes. That is, I think, is the most unique part of the whole program. So that apart from the knowledge, we are also imparting the skill, which is in alignment with the Government of India's Skill India policy. So, sir, give us a little idea of why this whole program looks or should be interesting and important for the working engineers and also for the fresh engineers who are coming into this industry, especially from the fields of electrical, computer sciences, metallurgy and all. So give an idea of why it is important.
Okay. See, one fundamental fact about human being is we try to understand things based on our past knowledge. So if you look at a fresher who has completed a lot of courses in
traditional engineering.
So when they come to the course, they will find that many of the things they have studied in their undergraduate is actually practically implementable and they can make a living out of it. That is the first thing.
True.
Now come to people who have experience. So let's say I'll take an example of a IC designer. So there are many companies which will design ICs, and there are many engineers who have many years of experience in IC design. But now when they take this course, they will have a clearer understanding of what they know about designing of IC. How is that implementable in a EV charging infrastructure? So if they have entrepreneurial behavior or entrepreneurial aspiration, so that will be excellent for them, because now they know that this is my knowledge that I am actually good at, and this is how it will be used in a EV charging infrastructure, right? So that way I think both working professional as well as freshers can take advantage of this course.
Right. And sir, from the perspective of the India's ever-evolving EV sector, because now EV is not only about vehicles, but different sectors are incorporating EV technologies, including that are UAVs, drone industry. Everybody is moving towards the EV technologies. So given that kind of a landscape in India, how you feel that this sector will provide the opportunities for our youngsters?
Okay. See, this is again a very important question. So, to answer the question, I will give you a brief overview of where I started from and where I am now. See, I was actually a IC designer, okay, who used to apply ICs to server power supply. So from there, when I became a faculty, I started doing renewable energy. Then I started doing server power supply. Then I started doing microgrids. Now I am doing EV. It is not like I have changed. I am the same person. So what I am trying to say is that once you develop these skills are applicable in many fields, which is exactly what you pointed out. When you understand how a power supply works, you can apply that power supply to a drone, you can apply that power supply to a consumer electronic device, to anything.
Yes.
Right. Similarly, once you know how a communication works, you can apply that communication to any field. So this course will give you the basics of power electronics, communication from the perspective of EV. But the knowledge gained by through this course or through any similar courses are applicable to
multiple
any
areas,
other field.
modern industry field. Yes.
Right.
Okay. Thank you very much, sir, for sparing your valuable time and telling us more about how this field is going to impact India's EV sector and how the student community will benefit in taking this program, and also how they can make a career out of it. Thank you very much for your time, sir.
Thank you very much.